In this video, I will be teaching you how to solve one problem on partial differentiation where higher order derivatives are integrated. So, provided that we have u is equal to x squared, y squared, z squared plus cosine xy ln z. So, we have to look for partial partial cube u. I think that's how you say it. I'm actually not sure, but this is essentially what we have to find. This. So, what does the 3 mean? Essentially, we do have 3 variables, right? So x, y, z. And in order to basically find this, we have to look first for partial u over partial y. And then after that, we have to look for partial u over partial z. So you might ask why that specifically. By the way, that's not complete. Partial z, partial y. So there is this concept wherein, so basically in the first part, you're given this notation, right? So the first that you have to find is this over this. The second one would be this. And then the third one would be, well, this one already. So starting from the right, going to the left. Okay. So let's try to solve first for this notation. Partial u over partial y. So we are going to consider x as constant. So x squared is put in one side. Y squared, z squared, we have to apply product rule. So 2x, no, x squared, derivative of x squared is 0. Wait. Sorry. Y squared, z squared. So 2y times z squared plus y squared times 2z plus, so the derivative of cosine u is negative sine u du dx. So negative sine u, and then the derivative of xy such that x is a constant, so 0 times y plus x times 1. Okay, I think here we have to apply product rule. So this is the derivative of cos xy. We copy ln z, and then plus copy cosine xy, and then derivative of ln z is 1 over z. Since z is just a variable, times 1, or you don't have to write that anymore. Okay, are we good so far? Let me just verify. Oh, wait. So apparently, it's not just x that's the constant, also z. I overlooked that part. I'm sorry. 2y z squared y squared 2z. This is supposed to be 0. Here, that's going to be 0. Okay, so those are the only things that you have to change. Next, simplify. So 2x squared y z raised to 2 minus sine xy x sine xy ln z. Okay. Well, yes, that's it. Actually, you can reorder. it as that. Okay, next. So how do you write the second notation? Let me remove that again. Let's start from the beginning. So coming from here, since partial z is the second, so write partial u over partial z and then copy what we had in the first, so partial y. The only difference is you add a squared, so this is our second basically. That's what it means. So in that case, uh, we come from what is provided as the answer to partial u over partial y. This time, we are going to render x and y as constants. So it is, I think from your perspective, it is understandable to think that x is still our constant, but why is y a constant this time? Usually, so far, um, whenever there is partial y in the denominator, y isn't considered a constant. But in the context of higher order derivatives, apparently that it is technically a constant. So you just have to know when it's a constant and when it's not in the context of HOD. So this is one of the rules. So yeah, moving on. Now that we know that x and y are constants, let's okay. So x 2x squared y, and then derivative of z squared is going to be 2z minus, set aside all of the constants, so x sine xy. What's left is ln z. The derivative of ln z is 1 over z. Okay? And then if you simplify, we're going to have 4x squared yz minus x sine xy over z. That's it. And then, finally, this time we have partial x. So now you know. This one is 2, this one is going to be 3. And after writing partial z, partial y, what we add left is partial x. So that's how we got this notation. Actually, if you think about it, coming from the notation that was provided, we're able to find out what we're supposed to find for specifically this and then this. So let's move this here. Actually, no. We'll be using this anyways. So here, we are going to regard z and y as constants. So let's think about that for a while. Why specifically y and z? Actually, to be honest, I'm not really sure why anymore. It's been 3 weeks, 2 weeks since I've taken the final exam. Z and y. So, in the first and second, we regarded x as a constant. But in the third, we no longer did. Anyways, best we don't take too much time on that part. Let's start deriving. So coming from here, we set aside the constants, right? So yz, and then 8x minus quotient rule? No. We set aside the constant, so that technically means 1 over z times x sine xy. The y here we cannot separate because it technically, if you visualize, it's technically like this. So sine u. You can't separate xy from the sine. So let's keep going. 1 over 3 times, I think I'm seeing a product rule here. So 1 times x sine xy plus 1 cosine xy, and then product rule for xy such that y is a constant. So 1 times y plus x times y is a constant, so 0. Sine xy plus y cos xy over z. Are we good so far? Wait a minute. This was supposed to be x. Not bad. So in that case, xy cos xy. Well, yeah, this is actually the answer already. Okay, so that's it for partial differentiation HOD. Let's I guess I'll just have it on the next video. Total differentials. That's it for this video. Thanks for watching.